Friends, we have clearly explained Newton's second law in my previous two videos and have solved some of the examples so that a better understanding is established. So, in this video, I will shortly cover more examples of the connected bodies which are important from the perspective of learning Newton's second law. But before again, briefly explain once again what is Newton's second law. It is nothing but F is equal to m into A, which you must know, where m is the mass of the body and A is the acceleration, and force is the external force acting on the body in the direction of the acceleration, which also is known as rate of change of momentum. So force is equal to the rate of change of momentum, and you know that momentum P is defined as mass into velocity, which if I differentiate with respect to the time or rate of change of momentum will give m dv by dt. dv by dt is rate of change of velocity, so this is m into a. So F is equal to dp by dt or F is equal to ma, both are synonyms, both are same. Now we come to the moving pulley concept. You must understand moving pulley concept because the questions that I have covered in this video relates mostly to the connected bodies with the moving pulleys. So here if you know, if the pulley is moving, in the green you can see there is an initial, this is the initial position of the pulley, and if I bring it down by an amount x, if it comes down by an amount x, what will happen? The both side of the string, the both side of the string which is connected to the pulley will go down by an amount x. So if the center has come down an amount x, what will happen? There will be a 2x displacement result in x. The string will have the displacement of 2x, which will result in the displacement of x downward of the moving pulley. So that is very important concept. In another case, you can say if the string is connected in such a way in the system so that one part of the string is able to have a displacement x and another is making a displacement y, so that the pulley will come down by a distance x plus y by 2. So it is actually the average of the displacement. So x plus y by 2. You must understand that the displacement of the pulley will be average of the two. Displacement is actually a vector quantity. So if by chance, if in any question something like that happens, that x is going down, this part of the string is going down, this is going up, then in that case the displacement of the pulley downwards will be given by x minus y by 2 if x is greater than y, or it will be in upward direction and will become y minus x by 2. So we will come to some of the examples which is very important and have been given in many books also. So you get this, you understand the solution. Here you see there are two pulleys. One pulley is this, another is this, and there are mass m1 and m2 which are connected to it. So I have drawn the forces here. There is a gravitational force of the mass m which is acting downwards. There is a gravitational mass of mass m2 which is acting downward, m1g and m2g. Now, if since you can see this pulley is moving, this particular pulley is moving, hmm, and tension is acting in the upward direction, and it is going in the downward direction. That gravity is in the downward direction. So it will all depend on the masses m1 and m2. So which, whether the pulley will move up or pulley will move down. So in that case, if C, we assume that m2 is greater than m1. So what will happen in that case if m2 will come down, which I have written, it is going down by an acceleration a2, then this pulley will go, or mass will go up by an acceleration a1. Now tension, you see it is all internal tension. There is a tension T since there is only one string. So tension T is being shown in this figure. So what now? I will apply the same concept. Now if the mass m2 is going down by an acceleration a2 and there is a tension T acting in the upward direction, so what will happen? As per the Newton's second law, you can see this equation. I am now covering it. It is m2g is acting in the downward direction and T is acting in the upward direction. So net force is m2g minus T will act in the downward direction, which is nothing but equal to mass into acceleration, which is m2 into a2. So this is one equation I have written here as an equation 2. Now I will come to the equation 1. Equation 1 means since m2 is going down, m1 is going up. So if m1 will go up, if this is going by a distance x up. Distance x up means the pulley is also moving by a distance x up. Now here the string is fixed. Here the string is fixed. So the displacement of this string will be 0. This will be 0. I will draw it with another color. So this will be 0. But here since it is going up, so this string has to move by a distance 2x. This will have to move by a distance 2x. If this will move by 2x, this will come down by a distance 2x. This will come down by a distance 2x, because in that case only, as I have explained, average of the displacement of the strings on two sides will be the displacement of the string. Since mass is moving by a distance x, so pulley will also move by a distance x. Okay, and this M2 will have a displacement 2x. So now I will come to this equation. Now here the total force 2t is acting up. 2t is acting up in the upward direction. M1g is acting in the downward direction. So net force in the upward direction will be 2t minus M1g, which is nothing but M1 into A1, which is Newton's second law. So there are two equations which are established. Here I have explained, I think you must have all understood by now, that if mass m1 is moving by a distance x up or displacement x, m2 will come down by a distance 2x by the moving pulley concept. Okay. So I am using, there are two equations, there are three unknowns, tension T1, A1, T, A1 and A2. So there are three unknowns. So I have only two equations available with me. The third equation is A1, I know it is d2x by dt square, and A2 is nothing but it is 2x. So I can write it as 2 times of d2x by dt square. So which is A2 is equal to 2A1. So I got the third equation also. So using these three equations, I can solve for A1, A2 and T. So this is one concept. Another concept I am telling in the same thing means this is a complete system. This is a complete system. I am again rounding it up. This is a complete system, and external forces are acting only on the gravitational force. Rest all the forces T, 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 whatever I have shown, they are all the internal forces of the system. So these internal forces will not contribute to any work done, because they will not contribute to any work done. Only external force will contribute to the work done. So if force into displacement is equal to the work done. So for this system, sigma of Tx for all the internal forces which are giving a displacement will be equal to 0. Here x is only a symbol. Okay, this is not related to this x. This x is different. So if I differentiate this, what I will get? I will get t into dx by dt, which is velocity. So t dv is equal to 0. And if I further differentiate, I will get sigma t into dv by dt, which is acceleration. So ta is equal to 0. So here this concept we are using, acceleration concept, and we will apply the same here to this problem. So for the mass m2, which is having an acceleration a2, and it is having a tension t in the upper direction, so acceleration and tension both are in the opposite direction. So this, you must understand one thing also, this dot is nothing but dot product. You know that force into displacement is equal to work done, which is a dot product. So minus t into a2, because both are in the opposite direction. So it will have cos 180 degree, which is minus 1. So T into A2, which is the work done by this tension force, and there are two tension force which are acting. 2T is acting on M1. So 2T into A1. A1, because they have the same direction, so I will use plus sign. 2T into A1 is equal to 0. So if I solve this and bring minus sign onto the other side, I will get 2a1 is equal to a2, which I got from the visualization or from the moving pulley concept, where I have used the average of the displacement of the two strings as the displacement of the pulley. So hope you would have understood this problem. I'll come to the other problem, second problem, which is little more extended to the first form. Here you see there is a mass A and there is a mass B. There are two masses A and B. And because of the whole system, I have drawn this whole system. This mass A is going down by an acceleration a1 and b is going up by an acceleration a2. Okay, so I'll use the same concept. First is, if sigma ta is equal to 0, so from this relation there are 6 t, 1, 2, 3, 4, 5 and 6. There are 6 t which are acting in the upward direction, and displacement of mass A is happening in the downward direction and acceleration is downward. So 6t and a1 are in the opposite direction. So I will write minus 6t into a1 plus, if for the mass B, what is happening? T is going upward and a2 is also upward. So they are in the same direction. So this is plus t into a2 is equal to 0, which will give a relation between a2 and a1, which is 6a1. So by this we can solve the problem. So other way of solving it by visualization, which I prefer, you must understand this also. So if this is going by a distance y, so the displacement of this string is 0 because this is fixed. So if this has to come down by a distance y, what will happen? This has to certainly come down by a distance 2y. Then only what will happen? It is 0 plus 2y by 2, which is nothing but y. Now if this string is coming down by 2y, this will go up by 2y. If this is going up by 2y and this string has to come, the mass is coming down only by a distance y. So what will happen? This will definitely, it is going by 2y, so this will come down by 4y. Then only what will happen? It is minus 2y plus 4y by 2 will give y. Now if this string is coming down here by 4y, so here this side it will go up by 4y, and again the whole mass is coming down by a distance y. So definitely this part has to go down by 6y. Then only what will happen? It is minus 4y plus 6y divided by 2 will give y. So what is happening? If this is going down by 6y, this will go up by 6y. Okay? Now you can see that displacement and of this one, if it is happening y, this is going up by 6y. If it is going up by 6y, so I can write d2x by dt square. If I write here as x, if I write here as x, so a1 if I defined as, it will become d2x by dt square by double differentiation. And if this is y, this is a2, a2 I can write as, if this I am writing as, suppose I write as z. So what will happen? It will be d2z by dt square, which I can write as 6 times of d2y by dt square. Okay, here x is y is same. I have to write here as y. So I can write here, this is 6 times of d2y by dt square. So a2 will become 6a1, which is the same which I have got by the earlier method. Now we will come to the third example. This example I will explain with the help of moving pulley concept only, so that you will have a better understanding of the concept. Here this is the system. Here you have a capital mass M. You have a capital mass M, which is applied by a force F, and there is a small mass M. So I have to establish a relation between A1 and A2. Once this relation between A1 and A2 is established, the rest of the question will become easy to solve. So here you can see, if I consider a displacement x here for the mass m because of the force F. So what will happen? This x will give rise to the displacement x of the pulley also, because this pulley is connected to the mass m and it's a moving pulley. So the moving pulley will move by a distance x, and from the concept of the moving pulley, this end is fixed. Since this end is fixed, so it will have a zero displacement. To make, therefore, to make the displacement of the pulley as x, for this pulley as x, this string has to move by 2x. So this clearly establishes that mass m will move by a distance 2x if capital mass m moves by x. Small mass m will move by 2x. So if I write A1 is equal to d2x by dt square, then what will happen? A2 will be nothing but d2x by dt square times of 2x, which is nothing but 2 times of d2x by dt square, which is 2 times of a2, 2 times of a1. Sorry, this is 2 times of a1. Therefore, I can write, therefore, a2 will be nothing but 2 times of a1. Now, from the forces also, if there is a tension T here in this string, this T will be applied here, T will be applied here, T will go like this, and again 2T will be the tension here, and this will have a repellent, this will be in the opposite direction. So capital M will have an opposite force of 2T. So if I apply sigma T A is equal to 0, so T into A2, because T and A2 are in the same direction for small mass m, and for capital mass M, 2T and A1 are in the opposite direction. Minus 2T times of A1 is equal to 0. So I can write T times of A2 is equal to 2T times of A1. So T and T gets cancelled. So what we get? A2 is equal to 2A1. So it becomes very easy from this concept also. I will come on to the example 4. Here I will first explain with the concept of the moving pulleys. If this 2 mass m is moving by a distance x or displacement x, so this will make this pulley to move by a displacement. It will also displace by an amount x. Now since this end is fixed, so this will have a zero displacement. Therefore, this string will move by a displacement 2x. So it will come down by 2x. So if it has an acceleration a1 here, and here it is an acceleration a2 here. So I can write a1 is nothing but d2x by dt square, and a2 will be nothing but it will be times of 2x. So a2 can be written as 2 times of d2x by dt square, which is nothing but 2 times of a1. So a2 will be nothing but 2a1. Clear? Now, from the concept of the force also, this is a tension T here, T will be applied here, T will be applied here, so 2T will be applied here, so 2T will be applied here. Now, 2T and X are in the same direction, so I will apply sigma T dot A is equal to 0. For mass 2m, what is happening? 2T and A1 are in the same direction, so I can write 2T into A1, and for T and A are in the opposite direction. They say that there is a 180-degree angle. So this is T times of A2 is equal to 0. So I can write 2T times of A1 is equal to T times of A2. Therefore, T and T gets cancelled. So A2 is nothing but 2 times of A1. So we got the same relation with this also. So any of the concept can be used to solve the problem. Once you get this, you can apply Newton's second law to both the bodies and solve for tension A1 and A2. This is how the problems are solved. Hope you would have understood.